A society of dice, a base 6 number system. Looking at our societies today, what common factor underlies many of our problems? Fingers. We count with our fingers a ton. This makes keeping track of things difficult because we could be doing so much more with our fingers. What do we do to fix that? Enter the base, or our dice. Rather than count with our fingers, every citizen of the world would be required to keep a bag of dice with them. These dice would be used to count numbers. This is useful for a ton of things, like calculating the cost of your morning coffee, deciding how much to pay your employees, and so much more. The base of our dice is 6, which means the set of available numbers for use would be equal to the set of A, which contains the elements 0, 1, 2, 3, 4, and 5. We would assign the numbers of the dice visually as such. 1 would be equal to 0, 2 would be equal to 1, 3 would be equal to 2, 4 to 3, 5 to 4, and 6 to 5. Color coding the dice would allow us to represent different place values as well as the value of the quantity of the place value. Gray would be the ones place, green would be the tens place, blue would be the hundredths place, purple would be the thousandths place, orange would be the 10,000ths place, teal would be the 100,000ths place, and rainbow would be the millions place. Writing. Our system is easy to learn. With dice at the core of our system, both visual and numerical elements play a key role, offering multiple ways to explore numbers. Our dice also play well with the base 6 system, which makes using them for counting a breeze. When representing numbers on paper, we would simply draw the dice and color them in. In terms of memorization techniques, people would begin associating colors with values. I see a blue dice and I think, oh yeah, that is the hundredths place. 0 in dice. A gray dice with a 1 written on it would signify the value of 0. A 1 on the top side of any dice will always represent 0 of a given place value. How does our new base compare? In terms of similarities to the Hindu-Arabic system, our system differs from this system. This is because we will be using dice to represent numbers rather than the actual number themselves. It is similar because it uses a base system and places values to quantify large numbers. And not to mention, we are operating with a base of 6 rather than 10. In terms of similarities to the Egyptian numeral system, our system is like this system as we will be using images to represent our numbers. The primary difference, however, is that our system will only operate in dice designated by color. So instead of a coil of rope signifying 100 of something, it would be a blue dice with a value of 2. We would also have dice representing the value of 0 in place of values such as 1 and 10. In terms of similarities to the Maya system, our system would be most resembling the Maya system visually. This is because of our repeated visual use of symbols in representing specific values. Multiple gray dice, for example, could resemble multiple groups of 5, as the Maya system does. For basic writing examples, the number 0 would be represented by a gray dice with the number 1. For the number 200, the number 200 would be represented by a blue dice with the number 3 on it, as well as one green and gray dice with the number 1. Continuing on, the number 14 would be represented by one green dice with the number 2, as well as one gray dice with the number 5. Delving even further into our writing examples, we can convert the number 10,532 to base 6, which is 120,432. The ones place would be a gray dice with 3, the tens place would be a green dice with 4, the hundredths place a blue dice with 5, a purple dice with 1 for the thousandths place, an orange dice with 3 for the 10,000ths place, and a teal dice with 2 for the 100,000ths place. Examples of Hindu-Arabic to base 6 dice. If we wanted to, for example, convert the number 777 in base 10 to base 6, we would take the number, divide it by our base, which is 6, take note of the result and the remainder, and then continue dividing the result by 6 for each value of the place value all the way down to 0. Doing this process gives us our number in base 6, which is 3,333. We can also exemplify this with the number 1,313, where we divide it by 6, take note of the result of the remainder, which is 218 remainder 5, 36 remainder 2, 6 remainder 0, 1 remainder 0, and 0 remainder 1, reading them from bottom to top, giving us our number of 10,025. Examples of base 6 to Hindu-Arabic. The number 3,333 in base 6 to base 10 would involve multiplying by our base of 6 to the power of the current place value. For example, 3 times 6 to the power of 3 would be 648. And then, continuing on, 108, 18, and 3. Adding these values together gives us the number in base 10, which is 777. Another example, being 10,025, shows that 1 times 6 to the power of 4 is 1296, and then 0, and then 0, and then 12, and then 5. Adding these values together gives us the number in base 10, which is 1,313. In conclusion, our base 6 system is easy to learn, easy to write with, and is easily converted between with other competing systems like Hindu-Arabic. Thank you.